Hello, and on behalf of Alfa Laval, thanks for watching this video. We are proud to be part of the Sustainable Refrigeration Summit. Alfa Laval is a leading global provider of first-rate products in the areas of heat transfer, separation, and fluid handling, with product system and services sold in more than 100 countries around the world. My name is Diego, and I'm the USA Refrigeration Manager for Braze Heat Exchangers, and with me, there is Tommy, our Corporate Refrigeration Sales Director, responsible for our plate and frames product line. Today, we'll be sharing with you Alfa Laval experience with natural refrigerants and how that is having an impact on our new technology developments. The stable base of everything we do is summed up in this very first slide title. We do carry on our activities helping our customer and partners in making our world better. We regard sustainability both as a necessity and as a business opportunity. Our technologies promote a more responsible use of natural resources, and we constantly drive progress to help reducing the environmental impact of most industrial processes. We contribute to improve energy efficiency and reduce emissions, and natural refrigerants are a natural consequence. And now I will leave the word to Tommy.
Thank you, Diego. There is definitely a growing trend of switching from synthetic global warming F-gas refrigerants to natural refrigerants. As you can see in the graph to the right, this is the second technology shift towards the green natural corner after the earlier where the market was replacing ozone depletion potential gases towards natural refrigerants. And what we can see to the right here is in Europe, where I'm from, already we are having more than 50,000 stores running with CO2. And the shift is projected to continue at a very fast pace. I suppose we will see a similar trend in North America. So what is then Alfa Laval contributing? Yes, in fact, Alfa Laval heat exchangers is an important factor enabling the successful transition. In short, Alfa Laval has made research and invested in development of several ranges of heat exchangers to cope with each of the refrigerant challenges and the need in the market. For ammonia, Alfa Laval is supplying heat exchanger to increase energy efficiency and safety using it in large supermarkets, cold storage, food process industry, ice rinks, and heat pumps. For carbon dioxide, Alfa Laval has developed products to handle efficiently this refrigerant with a very high design pressure in supermarket, but also in cold stores and process refrigeration. For propane and other hydrocarbon refrigerants, Alfa Laval has developed products to operate efficient in smaller systems, mainly for convenience stores and domestic heat pumps. We are now going to show you a movie about Alfa Laval determination to develop solutions for higher energy efficiency and reduction of emissions. If you, Diego, can launch that movie.
How do we both meet the need for more energy while simultaneously reducing the emissions that contribute to climate change? It's going to take a complete transformation of our global energy system. At Alfa Laval, we understand that there's no single or simple solution. It will require a complex combination of new technologies and fuels. And for decades, we've been hard at work developing advanced heat exchanger and separation solutions that will make it possible. Today, Alfa Laval's proven technologies are found in every industry imaginable, all over the world. Together with our customers, we're helping to maximize energy efficiency in a huge range of processes, enable the transition to clean energy, and secure a better use of natural resources to bring about a truly circular economy.
So Diego, will you go deeper into more details of what Alfa Laval can supply?
Yes, thank you, Tommy. So now that we've seen how Alfa Laval is developing all technologies keeping in mind a more sustainable future, let's narrow it down to our state-of-the-art heat exchangers, which specifically for refrigeration make possible cost and energy efficient supermarket refrigeration system using natural refrigerants. In details, what we provide to the supermarket industry is summarized in this slide. a wide full product portfolio specifically developed and dedicated to zero impact refrigerants. Both with brazed and plate and frame heat exchangers, we can offer components with different levels of pressure design and materials, covering all markets' needs for thermal, mechanical, and reliability performance, from small to very big refrigerant plants. Let's start with the CO2, maybe the most interesting natural refrigerants taking more and more space into today's supermarket application. For compact brazed heat exchangers, we're offering a full portfolio, going from very small unit, basically size of your mobile phone that you see to the left of this slide, to big units reaching 1890 refrigeration tons. Here you can see our model called CBXP and AXP for different levels of pressure design. We can match multiple thermal and pressure needs, taking also into consideration different space limitations you might have into your system. Without going too much into the details of every single model performance, you can immediately notice a big difference here going from left to right. When you grow in size and capacity, we do need reinforcement in order to match extreme levels of pressure rating. As you can understand, this will add more material to the heat exchanger itself, meaning possible additional space, cost, and weight. Here comes our latest development in the CO2, keeping in mind a need for extremely reliable components while at the same time giving the market a cost benefit. The question is how to make bigger units capable to deal with an extreme pressure, at the same time not adding material, space, or cost. Well, the answer is our brand new AXP82, today ready for the market. A frameless heat exchanger, as you can see in this slide, capable to bear 2030 psi of pressure design within a very compact space and no additional reinforcement. It's therefore intuitive that also cost is drastically reduced, giving a significant saving compared to traditional solutions. We've created this product with carbon dioxide in mind, redesigning all internal features as you can read on the right-hand side. And related to those, I would like to stress a little more on the last point, the fatigue resistance of this unit. So not only this product makes you able to deal with the extreme pressure of the CO2 systems, giving you a performance and cost-effective component, but it will also add reliability to it, thus less future maintenance cost. Thanks to the way the new XP82 is designed, we've seen an improving factor of both thermal and pressure fatigue, which can easily be translated in a longer life cycle of the component, therefore of your final installation. To finish with our latest news in the CO2 world, we're almost ready to release prototypes of our brand new CBP 540, of which you can see here some features and a sketch. The first evaporator in the market, able to deal with 870 psi, perfect also for air conditioning application where carbon dioxide is the refrigerants available in the plant. Going back to propane, typically used in small systems to keep the charge of refrigerants very low, we've developed a unit which guarantees the restrictive 150 gram limits and has an internal plate pattern which delivers high thermal performance. All this is possible thanks to the high ratio asymmetric channels, where the refrigerant channels is smaller than the liquid channels. This translates in less volume and higher turbulence to the refrigerants, assuring low charge and a good thermal performance, and at the same time, increase liquid content and passages, thus decreasing the pressure drop, therefore saving energy as a result. Tommy, now back to you to talk about the ammonia applications.
Yes, so turning to ammonia. For ammonia at small capacities, our full stainless steel Alfa Nova here presented is our solution. It has no copper, so it can work with cope with ammonia. Plus, it guarantees high level of pressure design thanks to its reinforcement, which is useful in many plants like small chiller or heat pumps with ammonia. If we move to larger ammonia systems in supermarkets and cold storages, I want to present a safe and efficient way of applying the natural refrigerants of ammonia. Reducing the quantities of ammonia is very important, and we have developed a technology with increased safety, minimizing the ammonia charge. In principle, it works like, as in the drawing here, you can see that we have a refrigeration installation in the cold storage. Within the blue area, we have the the cold space, and where we have a secondary fluid that is circulating to the various coolers. It can be glycol, brines, or even CO2. And the ammonia is kept in the machine room, and by that limiting the amount. And for such installation, it's needed a very good intermediate heat exchanger transferring the refrigeration load to the cooling room. That intermediate heat exchanger here presented in the middle of the ammonia circuit and the secondary fluid, we need a heat exchanger that can deliver efficient close temperature approach, keep a very low ammonia hold-up volume, and that can handle design pressure very high if CO2 is a secondary media, and be resistant against fatigue forces from cyclical patterns of temperature and pressure. And if you use a corrosive brine with salt, corrosion resistance, for example, is very important. For that, we have a dedicated range of heat exchangers. They're called the semi-welded plate heat exchangers. And here we have made a comparison of some important parameters to show the benefits of applying this modern technology instead of a traditional shell and tube type heat exchanger. For example, the energy efficiency can increase by 6 to 12% because we can have a very close temperature approach in this duty. We can cope with the design pressure of CO2 as a standard option. And the corrosion resistance is there because our standard material is stainless steel. And if you need further, there is also titanium options. And the fatigue resistance is very high due to its flexible design with the plates kept together with bolts. And the ammonia hold-up volume is very low. So these are the advantages. It shows that this plate heat exchanger is the heat technology of choice for this application. The full range of this product is available from our supply chain in Richmond, Virginia. And the benefits are all included. High efficiency, it's space saving, minimizes the ammonia charge to make the installation safe, and minimizes the requirements of any regulatory norms, and with a very reliable operation. So after that, I think it's time to move forward.
Yeah, thank you, Tommy.
Yes.
So before ending this recording, let me just go back to the sustainability topic, highlighting you how Alfa Laval is fulfilling most of the United Nations global goals for 2030. And for sure, the climate action is a key target, both on technology development and the supply chain improvements, as you can read in this slide. So with this said, I'm leaving you with a short video from our Corporate Business Development Manager for Clean Technologies.
We believe that in order to solve the two challenges, decarbonization and the shift to circular economy, we need to work together. Collaborations and strong partnerships will be key to develop the sustainable solutions. We have the technologies. Let's make it happen. Together, we can accelerate the transition to a more sustainable future.
Great. So now we see the video, and now we'll leave it to Tommy for the final slide.
Yeah, but Diego, that I think is all for us today. I would like to thank all of you for your attention, and please welcome to contact any of us or enter Alfa Laval website where further information and contact information are available. Have a good day. Thank you.
Thank you, everybody.
Bye-bye.